Student, when you want to do any problems, any exercise, you must be thorough in all the chapters. In particular, number system, basic algebra, algebraic formula and all. Normally, when you learn the problem, take some 10 to 15 problems from the textbook and read the steps, again do it, repeat it and remember it, by heart it, do that. That is not the case. When you see a particular problem, you should have the efficiency to solve yourselves. You should do the problem. For that, you must know all the basics. So, I just gave some information about laws of indices. So, when you write any number x power m, x is the base and m is the power. We can also call that as index, exponent, x to the power of m, like that. Right? Now listen, x to the power of m into x to the power of n, base remains same. I can add the power. This is called what rule? Product rule. I can say it is product rule. See, x cube into x square, I add the power. X power minus 3, x to the power of minus 2, I can add the power. Say 10 power 8, 10 power minus 9, 10 to the power of minus 1, power is added. Now, x to the power of m divided by x to the power of n, x to the power of m minus n. Remember, power should be same. Right? The power differs. This rule doesn't apply. This is called quotient rule. See, x to the power of 10 by x to the power of 2, x to the power of 10 minus 2, x to the power of 8. Say x to the power of 8, x to the power of minus 3, 8 minus of minus 3, x to the power of 8 plus 3, x to the power of 11. This is division or quotient rule. Next, x to the power of m whole power n, x to the power of m into n, I multiply. This is called power rule. Listen, x cube whole square, x power 6, x power m whole power n, just now I said x to the power of mm, x raised to minus 3 whole raised to minus 2, x to the power of 6, like that. X power m whole power n, x power m power n. And certain conversions also I will give you. You can use it for other areas also. You are aware? X power 0 is 1, anything to the power of 0. 1 by x, you can write as x raised to minus n. 1 by x power n, you make it as what? X raised to minus n. Root of x, you can write as x power half. When you multiply root x into root x, you will get x. 1 by root x, 1 by x power half, that is x raised to minus half. 1 by nth root of x, 1 by x to the power of 1 by n, x raised to minus 1 by n, is it not? Look, first trigonometric identities. Sin square theta plus cos square theta is 1. The proof I will be doing in a different session. Now, exclusively meant for to solve this trigonometric identities problem. Now look, sin square theta is 1 minus cos square theta. From this, sin theta is root of 1 minus cos square theta. Okay? Now look here, this I can write as, I use algebraic identities, 1 plus cos theta into 1 minus cos theta. Alright? The same way, cos square theta is nothing but 1 minus sin square theta. Cos theta, root of 1 minus sin square theta. That is nothing but 1 plus sin theta into 1 minus sin theta. This is one identity, right? And now, 1 plus tan square theta is secant square theta, second identity. From this, tan square theta is secant square theta minus 1. Tan theta is square root of secant square theta minus 1. That is secant theta plus 1 into secant theta minus 1. This is the same way. Secant square theta minus tan square theta is 1. This is another identity. Now listen. 1 plus cot square theta is cosecant square theta. So, cot square theta is cosecant square theta minus 1. From that, cot theta is root of cosecant square theta minus 1. That is square root of cosecant theta plus 1 into cosecant theta minus 1. So this is another identity. Also, cosecant square theta minus cot square theta is 1. So I just reflected three different identities. The same way, listen here, reverse. 1 by sin theta is at cosecant theta. That means sin theta into cosecant theta becomes 1. I said 1 by cos theta is secant theta. So, cos theta into secant theta is 1. I said 1 by tan theta is cot theta. So, tan theta into cot theta is 1. The same way, listen. Sin theta by cos theta, tan theta. Is it not? The same way, cos theta by sin theta, cot theta. So you should remember all these things. Now we start the problems. I just told you to solve any problem, whether it is easy or complicated in trigonometric identities. You should be thorough in algebraic identities. You must be thorough in the trigonometric ratios. You must read very well all these trigonometric identities. That is very important. Listen here. So you take the left hand side, simplify using identities and bring this right hand side. Sometimes what will happen, you take the right hand side and bring this left hand side. The problem is little complex and complicated. You may be in a position to take left hand side final simplification, right hand side final simplification, it may be equal. First, let us try with some simple sums. Listen. Prove that 1 minus sin square theta into secant square theta is 1, right? So I take this left hand side, you go to these identities. In sin square theta plus cos square theta is 1, is it not? There I worked. See, 1 minus sin square theta is cos square theta, is it not? This part. And the secant square theta, you know, just now I told you 1 by cos square theta. Cut this, I am getting 1, which is nothing but your right hand side. You have proved right hand side is equal to left hand side, is it not? How simple it is. Come to this next problem. 1 by 1 plus sin theta plus 1 by 1 minus sin theta is 2 secant square theta. Here again what? I take this left hand side. What is this left hand side? 1 by 1 plus sin theta plus 1 by 1 minus sin theta. Take LCM as 1 plus sin theta into 1 minus sin theta, right? Here you have 1 plus sin theta, so 1 minus sin theta goes here. 1 minus sin theta, 1 plus sin theta goes here. Plus and minus. Plus sin theta minus sin theta got cancelled. 2 divided by, this is a plus b, a minus b, a square minus b square. 2 by 1 minus sin square theta is cos square theta. What is 1 by cos square theta? Secant square theta. So this is 2 secant square theta. So right hand side as cot. So this is how you can prove. We will take one more problem. Sin theta plus cosecant theta the whole square plus cos theta plus secant theta whole square is 7 plus tan square theta plus cos square theta, right? We'll see. We take this left hand side. I have taken sin theta plus cosecant theta whole square plus cos theta plus secant theta whole square for this a plus b whole square, is it not? Sin square theta 2ab 2 sin theta cosecant theta plus cosecant square theta, is it not? This again a plus b. Look, cos square theta plus 2 cos theta secant theta plus secant square theta, right? Now listen, I take this sin square theta, I take this cos square theta combined. Plus, I take this 2 sin theta cosecant theta is 1 by sin theta, right? I take this 2 cos theta secant theta is 1 by cos theta, and I take this cosecant square theta is nothing but 1 plus cos square theta. I take this secant square theta is nothing but 1 plus tan square theta. Look, sin square theta plus cos square theta 1 identity. Cancel 2, cancel 2, 1, 1, right? The remaining what? This tan square theta, this is cos square theta. 1 plus 2, 3, 5, 6, 7 plus tan square theta plus cos square theta. Got this result. Is it not? Wish you all a good luck. Thank you.